Okay, let's do something different here. Let's compare the reactions between copper. Let's compare cobalt and nickel and copper and their reactions to different reagents. As we can see here, they exist in water as so. When we say a D block metal exists in water as a solution, it exists as so as an aqua complex. The cobalt ion solution is pink in color, nickel is green, copper 2 plus is light blue in color, while copper plus is colorless in color. If we were, let's talk about passing hydrogen sulfide gas into this. The cobalt ion will react with hydrogen sulfide gas in basic medium to produce a black color precipitate, cobalt sulfide. Nickel will do the same and also form a black precipitate, which is nickel sulfide. And nickel sulfide, it is soluble in hot concentrated nitric acid or aqua regia, while it is partially soluble in excess dilute nitric acid also. Copper, however, copper 2 plus is unique because it can react with hydrogen sulfide in any medium, acidic or basic, and it also forms a black color precipitate, copper sulfide. Now let's talk about the reactions with excess chloride ion or conc hydrochloric acid as well. If we were to add excess chloride ion solution into the cobalt ion solution, we get a blue color precipitate, tetrachloridocobaltate 2 ion, COCl4 2-. If we do so with nickel, we get a yellow color chloride complex. Same formula, just replace cobalt with nickel. NiCl4 2-, tetrachloridonickelate 2 ion. And the interesting thing about it is that it is yellow color when aqueous and blue color in alcoholic solution. Copper, it also reacts with excess chloride ion solution, and eventually it forms a yellow color chloride complex, which tetrachloridocuprate 2 ion, CuCl4 2-. However, it does so while passing this green color intermediate, CuCl plus. Now let's talk about the reactions with ammonia, excess ammonia. If we were to add excess ammonia into the cobalt ion, we get this, a yellow-brown color amine complex of cobalt, hexaamine cobalt 2 ion, which is yellow-brown in color. If we were to add an oxidizing agent into it, like permanganate or dichromate or hydrogen peroxide, the cobalt gets oxidized into from +2 to +3 oxidation state and forms the red-brown color amine complex known as hexaamine cobalt 3 ion, CONH3 3+. And here's an interesting reaction. If we were to add hydroxide ions into this amine complex, we will get the black color precipitate of cobalt 3 hydroxide. This is cobalt 3 hydroxide, and we can also we can reduce this to using reducing agents into cobalt 2 hydroxide, and we from that cobalt 2 hydroxide we can also add an oxidizing agent and get this also. I haven't written it down over here. If we were to add excess ammonia into nickel, we get a deep blue color amine complex, hexaamine nickel 2 ion solution, which is as so. And if we were to do the same with copper 2 plus, we also get a deep blue color amine complex. Here this is hexaamine. Here it is tetraamine copper 2 plus ion. and if we were to, we can reduce it into tetraamine copper 1 ion, which is colorless, and we can oxidize it back simply by exposing it into air. Say instead of ammonia, we simply add aqueous ammonium ion solution or hydroxide ion solution. They will form their respective hydroxides as precipitates. Cobalt forms its pink color cobalt hydroxide, cobalt 2 hydroxide, let me specify, and the green color nickel hydroxide, and the light blue color copper 2 hydroxide. While cobalt forms its hydroxide, it passes through a blue color intermediate, which is as so. Also, we can react cobalt 2 hydroxide, the pink color precipitate, with an oxidizing agent and get the black color cobalt 3 hydroxide. All of these hydroxides are insoluble in further addition of hydroxide. Now these are miscellaneous reactions, but let's go through them anyway. If we were to add cyanide ions into nickel ion solution, we get the light green color precipitate known as nickel cyanide. However, under further addition of cyanide ion solution, we get a cyanide complex, this yellow color solution, tetracyanidonickellate 2 ion, NiCN4 2-. If we were to add excess iodide solution into copper 2 plus ion, we get the dark white color precipitate known as copper iodide, and we get the evolution of the brown gas iodine. Under further addition of the iodide ion, we get the dark brown color I3- solution. This is copper plus, the cuprate ion, cuprate. If we were to add concentrated nitric acid into the cuprate ion, we get the blue color cuprous nitrate, and the evolution of NO2, nitrogen dioxide, which is a brown color gas, and water. This is a specific reaction for Cu+. Now remember dimethylglyoxine. If we add dimethylglyoxine into the cobalt ion solution, we get a brown color precipitate, and if we add dimethylglyoxine into a nickel ion solution, we get a red pink color solution. If we were to reduce the cupric ion solution in basic medium, we get cuprous oxide. It's in +1 oxidation state. See, +2 +1 reduction, and cuprous oxide is a brick red color precipitate. If we were to take copper 2 hydroxide, cupric hydroxide, which is a light blue color precipitate, a light blue color solid, and we were to heat it, we get a black color solid, cupric oxide, copper 2 oxide, and we get water also. This is comparing the chemistries of cobalt, nickel, and copper.